Welcome. Let's understand natural exponential decay. The function that we have here in the middle, it is the function that we can use to represent a natural exponential decay. Let's understand this equation. The reason why we can call it an exponential equation, it's because the variable of x is on the exponent. When we let the base of this exponent be the Euler number, that's when we can categorize it as a natural exponential function. And this parameter of a will always represent the y-intercept of this function. But why is it that this function will always represent an exponential that is decreasing? Well, let's take a look at the function one more time. Knowing that the Euler number has an approximation of a value of 2.71, let's substitute that approximation into our function. But let's not rewrite this exponential with a negative exponent. Let's rewrite it with a positive exponent. So just a reminder, to go from a positive to a negative exponent, we take the reciprocal of the value. We went from 2.71 over 1. When we take the reciprocal, the denominator becomes the numerator, and the numerator becomes the denominator. But now that we have written our equation with the positive exponent, let's take a look at the value of the base. 1 divided by 2.71, it's approximately 0.369. So really what we have, it is a positive base that is less than 1. And this is the reason as to why we will have a decreasing exponential function. Now let's take a look at the graph for an exponential decrease, and let's summarize what we have said. Because our base, it's lower than 1, we're going to have a decreasing exponential, and the y-intercept of this exponential will always be the value of a. We will always obtain an intersection with the y-axis at the location of 0, a. Now let's concentrate in our last question. Is there any way to make this exponential function decrease faster? Let's take a look at the following illustration. The graph on the right is a representation of the natural exponential function. Notice that the base is e, and the exponent is negative x. In this illustration, we are assigning a value of 1 to the parameter of a, so we should have a y-intercept at 0, 1. Now let's start increasing the value of a, and let's see how does that affect the function in the right. Right now we are assigning a value of 11 to a. Notice that we have a y-intercept at 0, 11. But if we keep increasing this value of a, notice that my exponential, it's decreasing faster. The left-hand side of our graph, it is becoming more vertical. The same can be said about the other direction. If we start decreasing the values of a, my exponential is going to decrease at a slower rate. Notice that there's more of a curvature to our function. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.